Hello, hope you are all well and doing good. I welcome you all to my this YouTube platform where you get lectures on the topics of chemistry. Now, last time in part one of the that video which was formed on the chemical properties of aldehydes and ketones, we were stopped at this reduction reaction stage where we discussed couple of reduction reactions of aldehydes and ketones, the two well-known reduction methods. The first one was reduction to alcohol and the second one was that reduction of ketones to pinacols. Now this time we will discuss another important reduction reactions of aldehydes and ketones, and that is reduction to hydrocarbons. Now this reduction of aldehydes and ketones to hydrocarbon is very important, both from board examination point of view as well as from competitive examination point of view. So in this method where we talk of reducing the aldehydes and ketones to hydrocarbons, the two well-known and the classical methods used in practice for long time, these are Wolff-Kishner reduction and Clemmensen reduction reactions or methods. So have a look at these two important reduction reactions of aldehydes and ketones to hydrocarbons. Now in simple language, what happens? A reduction of carbonyl group in aldehydes and ketones that gets reduced to a methylene group. Now what is that methylene group? Simply CH2 group. CH3 group, you all know, that is methyl group. CH2 group is methylene group. Then simple single bond CH single bond, that will be methine group, METHINE. Okay, now let us discuss these two well-known reduction methods, Wolff-Kishner reduction and Clemmensen reduction. So first of all, what is this Wolff-Kishner reduction? What happens in this? In this method, the aldehyde or ketone is heated with hydrazine. Hydrazine is NH2NH2. This is the chemical formula of hydrazine. In presence of a base usually taken sodium hydroxide or potassium hydroxide in a highly boiling solvent such as ethylene glycol. Okay, so this is the general formula of a ketone. So in presence of, it gets transformed first into hydrazone, and then in presence of that solvent and upon the action of a base, it gets converted into hydrocarbon or CH3 with the evolution of nitrogen gas. Now what would be the name of this? That depends upon the nature of R group. Remember, R and R dash can be both alkyl as well as aryl group or even hydrogen. So this can be aromatic carbonyl compound as well. Now what about the mechanism? For example, this is a ketone molecule. What happens? First of all, this upon a reaction with the hydrazine gets transformed into hydrazone with the elimination of this water molecule, H2 from hydrazine and O of this carbonyl group of ketone, and we get this hydrazone, which upon the action of a base, OH negative is here released by the base taken either sodium hydroxide or potassium hydroxide, and this gives this type of intermediate in which we are showing two dotted bonds here as well as at this side. Now obviously we were having double bond between nitrogen and carbon. It means this dotted bond represents the breaking of this double bond, and this another one, this represents the formation of double bond here as is shown here. Okay, and this is also RDS, that is rate determining step of this reaction, that is diimide formation, diimide ion formation, which is formed here. This is the rate determined step in Wolff-Kishner reduction. This can be asked as MCQ in competitive examination. A rate determining step in Wolff-Kishner reduction is the formation of this diimide ion. Okay, so what happens here, I will again tell you that double bond is going to be formed here, and that is getting broken down at this side. Okay, so what happens, a sort of rearrangement also takes place here in this step. This hydrogen, when double bond will be formed here, this hydrogen atom will get attached to this carbon as shown here. And what happens in the subsequent step, loss of this N2 takes place, loss of this nitrogen molecule takes place, and the electron pair between nitrogen and carbon gets shifted on to this carbon atom, thereby giving this type of an carbon ion, which upon the action of a base ultimately gives this hydrocarbon. And that here in this step we can also say that the water molecule that was released earlier, that will give simply H to this carbon bearing negative charge, and this species will simply get transformed into hydrocarbon. Okay, hope you have understood. So this is simply what is called as Wolff-Kishner reduction, simply the conversion of a carbonyl compound upon treatment with hydrazine in presence of a base and a highly boiling solvent like ethylene glycol, that gets transformed into hydrocarbon. This is Wolff-Kishner reduction. Okay, so you can take screenshot of it. Okay, now let us move ahead. Another way to convert or transform this carbonyl compound, that aldehyde or ketone, to hydrocarbon is Clemmensen reduction. Wolff-Kishner reduction takes place in, remember, Wolff-Kishner reduction takes place in basic medium. Now Clemmensen reduction, यहाँ पर भी कार्बोनाइल कंपाउंड ट्रांसफॉर्म होगा, कन्वर्ट होगा हाइड्रोकार्बन में, but this reaction takes place in presence of or in acidic medium, HCl. You are seeing here the medium that is being utilized here is HCl. So this reaction consists of heating the aldehyde or ketone with zinc amalgam and aqueous HCl. Ketones are reduced more often than aldehydes. So this is a general formula of presence of zinc amalgam and hydrochloric acid as a medium, and this carbonyl molecule or this carbonyl compound gets transformed into hydrocarbon. Now what is amalgam? You all might be knowing that alloys are the homogeneous mixture of two or more metals. Now if one metal is fixed as mercury, then that sort of alloy is called as amalgam. Okay, so what about the mechanism of this transformation or of this reaction? Have a look here. Have a look at this mechanistic pathway, where what is happening at the very first step, the carbonyl group of this ketone molecule, what is happening here, hydrogen or H positive or proton from acid is being taken up by this oxygen by means of its lone pair, and hence this is getting transformed into OH positive, because lone pair of oxygen is being utilized for abstraction of proton. Hence positive charge generates on oxygen. Now since oxygen is more electronegative than carbon, therefore oxygen tends to attract this shared pair of electron lying between carbon and oxygen towards itself, thereby making carbon as an electron deficient site, at which zinc atom donates its lone pair and thereby eventually making it carbanion or negatively charged carbon, and zinc itself gets released as zinc 2 positive ion, because it is more electropositive reactive, and as a result of that tendency it just donates its electron pair to carbon and itself gets released as zinc 2 positive ion, and we are getting this sort of species. So what is happening in the next step, this negatively charged carbon gains a proton from the medium, and this hydroxyl group also gains a proton from the medium. So simultaneously two protons are being utilized here. One goes over here, this carbon bearing negative charge, and another goes over here with this hydroxyl group, and because of this hydroxyl group gets changed to OH2 group. That is, now here a molecule of water will be lost, because by the abstraction of proton by the lone pair of this hydroxyl group, oxygen acquires positive charge. Now since oxygen being more electronegative, it attracts this shared pair of electron towards itself, and thereby making again this carbon positively charged or deficient, electron deficient, at which another zinc atom donates lone pair of electrons, and zinc itself getting released without electron pair, that is as zinc 2 positive ion again, and making this species as carbanion type species, as shown here, which ultimately gains a proton from the medium, and this CH negative this gets transformed into methylene group, that is CH2, and we get molecule of hydrocarbon. Okay, what will be the name of this hydrocarbon molecule? That depends upon the nature of R and R dash, and R and R dash can be both alkyl as well as aryl, or it can be hydrogen attached here as well. So you are seeing here that during the course of this overall reaction, what is happening, this is first proton that is being utilized first, these are here 2, so 3 protons, again in the last step 4 protons, and these 4 protons come from medium, that is ICl. So if 4 protons are being utilized, it means 4 chloride ions are also released there. So 4 chloride ion getting combined with the 2 zinc 2 positive, and thereby giving 2 molecules of zinc chloride. Okay, so 4 Cl2, 2 into 2, 4 4 chloride ions and 2 zinc. In here 1 and this is another one, so 2 zinc. So we are getting 2 zinc chloride molecules here during the course of this reaction. Hope you have understood. This is quite simple mechanistic pathway. Okay, so you may take screenshot of it. Okay, so I will bring to you some more stuff regarding this chemical properties of aldehydes and ketones. We are left with very few points. Till then, goodbye, take care.